Good morning, guys. I am unable to be in school today due to an appointment. Um, I will give you your quizzes tomorrow when I'm back. Today we're just going to do a quick lesson on factoring, probably 10, 15 minutes tops, and you have some time to work on a worksheet. Hopefully get that done before you leave. So we're going to intro our next section in the next couple days, and then we'll be on our break. So you should have your factoring methods worksheet from the sub. They're in the sub folder. All right, and we're going to start going through our first couple methods. So as we get started, the first method is the greatest common factor, which we'll refer to as GCF. We look to do this every time right away if it's possible. So like in the first example on the left, the greatest common factor is the biggest number you can divide both terms by. So we have two terms, 3x squared and 24x. So we can divide 3 and 24 by 3. So our GCF will come out front, which is 3. And both these terms also have an x we can take away. So the x will also come in front because they have an x in common. It's something they both have. So what we'll do is put a parenthesis because everything left over is going to go in the parentheses. So if we divided 3x squared by 3x, 3 divided by 3 is 1. X squared divided by x is x. Do the same thing for our second term. We divide by 3x. 24 divided by 3 is 8, so it's minus 8. And x divided by x is disappears because x over x cancels. So it's kind of like undoing the distributive property. So this is our factored form. If we were to distribute this, like take 3x times x, you would get 3x squared. And if you took 3x times negative 8, you would get negative 24x. So it's kind of like undoing the distributive property. Okay, and then in the second example over to the right, there are now 4 terms. 1, 2, 3, and 4. So if you look at those 4 terms, we're trying to find what they have in common. So let's focus on the number first, the coefficients, 3, 24, 2, and 5. Is there any number you can divide 3, 24, 2, and 5 by? And you have to be able to divide all of them by this. So like 3 and 24 we can divide by 3, but we can't divide 2 by 3. So actually the biggest number we can divide them by is 1. So our GCF would have a 1 in it. And then look for a common variable. The variable they all have in common is x. And we'll always take out the common variable. You look at the lowest exponent. And the lowest exponent is x to the first. So if we took out an x and put that in the front, what will be left over if we divided everything by x? So 3x squared divided by x is just 3x. 24x divided by x is 24. 2x to the third divided by x is positive 2x. Sorry, 2x to the fourth divided by x is 2x to the third. And then 5x to the third divided by x is 5x squared. So we took out our GCF, and that's what we would get. So trying to find the biggest thing you can divide both terms by. Okay, and if at all I move too fast at any time, just hit pause. I'm going to keep moving along just so I don't go too slow for you. All right, the next thing we're going to do is difference of squares, which is when there are 2 terms. So 2 terms, we check for difference of squares. This must be a subtraction of 2 perfect squares. Okay, when I am back tomorrow, I will get you perfect square cards that you can use. Okay, perfect squares are like 1 squared is 1, 2 squared is 4, 3 squared is 9. So those are the perfect squares. So in the first one we have x squared minus 9. And to start, I'm going to show all the work. the square root of x squared equals x. So that is a perfect square. And over here, the square root of 9 equals 3. So what we have here is two perfect squares, and they're subtracted from each other. So this is a difference of squares. To factor this, it's two sets of parentheses. The square root of the first term is x, so that comes first. The square root of the second term is 3, that comes second. And then our symbol is going to be a plus and a minus. So 1 plus and 1 minus. So it's as simple as that. You find the square root, and then you do 1 plus, 1 minus. Okay, and the second one, actually I should change this one. Okay, we'll do it this way. I didn't intend for this problem to be like this, but I must have screwed up. So if you look at the second one, there's actually two parts to it. There is a GCF, so remember we check for a GCF first. Both of these numbers, 104, can be divided by 2. Actually, screw that. They can be divided by 4. Excuse me. So we can divide them both by 4. When you divide by 4, we get x squared minus 25. So we do a GCF first. So let's put over here, GCF. And then if you look in parentheses, x squared is a perfect square, and so is 25. So we're actually going to split this apart into two parentheses and put 4 in the front, because that 4 stays there. The square root of x squared is x and x, and the square root of 25 is 5, so we have a 5 and a 5. And then there's 1 plus and 1 minus. So we end up with 4 times x plus 5 times x minus 5. So we had to do a GCF, and then we did a difference of squares. So this one had multiple parts. Okay, I'll keep moving along. Our next one, we're going to factor this completely. It's going to be either a difference of squares, a GCF, or a combination of both. So number 1, 24 and 30, the biggest number they can both be divided by is 6. So 6 comes out front. And then the most x's we could take away from the first term is x to the third. And we can also take away x to the third from the second term. So x to the third is also in our GCF. So if we divide everything by 6x to the third, because that is our greatest common factor, we will get 4 minus 5x. And then if we check in the parentheses, we cannot factor that anymore. So this is as far as we go. 6x to the third times 4 minus 5x. Okay, number 2. There's two terms. First we check for a GCF. There is nothing you can divide 25 and 121 by. So after that we check to see, are they perfect squares? The square root of 121 equals 11. And the square root of 25x squared is going to be, the square root of 25 is 5, and the square root of x squared is x. So we have two perfect squares. So what we do with this now is break it apart into two parentheses. The square root of the first term comes first, so 11 goes first. The square root of the second term comes second, so 5x and 5x. Then we have a plus and a minus. So 11 plus 5x, 11 minus 5x. Okay, and then we go to number 3. Number 3, and again, if I'm moving too fast, just hit pause. For number 3, we have two terms. we always check for a GCF first. We can divide 8 and 72 by 8. So we're going to divide these by 8. We're going to put parentheses after it. So the 8 goes in front. That's what we're dividing by. That's our GCF. 8 divided by 8 is 1. So we have 1x squared. 72 divided by 8 is 9. So we have 8, and then we have x squared minus 9. Right. Then you look at the parentheses, and we can actually factor this again because there are two perfect squares. X squared is a perfect square, and so is 9. So we break it apart into two parentheses. The square root of x squared is x. The square root of 9 is 3. So we get a plus and a minus. And then we have to keep that GCF in the front. So we have 8, x plus 3, x minus 3. That's as far as we can go. Right, so that was GCF, and that was difference of squares. We have one more left, just for today. The last term we're going to cover today is called grouping, and this happens when there are 4 terms. So you look at the 4 terms, 3x squared, 24x, xy, and minus 8y. So if there's 4 terms, we still check for a GCF. If you look at the coefficients 3, 24, and 8, there's not one number we can divide them all by. If you check for variables, 3 of them have an x. The first, second, and third term have x. The fourth term does not. So what we do now is, since there's no GCF, we're going to group the first 2. I'm going to group the second 2. So for grouping, you divide them into 2 different groups. And then we check in this first group, is there a GCF we can take out? So there is. We can divide them by 3x. So what happens in the first group is the 3x comes in front. Whatever's left over comes after that. So if we divide the first group by 3x, 3x divided by 3x is x. Sorry, 3x squared divided by 3x is x. And then negative 24x divided by 3x is minus 8. So basically we did a GCF for the first group. The second group has a GCF of y. And it was a positive y. So we're going to put plus y. And then we have parentheses. When we take away a y or divide by a y from the third term, we get x. And when you divide by y for the last term, you get a negative 8. So we grouped it, and we took out a GCF for both. Okay? So now we have GCFs. If you look at what's left, there's something that's the same in both of these terms. They both have an x minus 8. So we're going to take that x minus 8, since they have this in common, and that's going to come in the front. So you took out the x minus 8. If you took that out and put in the front, you don't have to do this, but I'm going to cross these out. What's left over? 3 plus y. So 3 plus y comes second, and we put that in parentheses. And this is our factored form. X minus 8, 3 plus y. And we're going to stop right there. I know we covered 3. It's quite a bit actually, grouping, GCF, and difference of squares. There's the 12 problem worksheet. I know with me not being here, if you have questions, it might be hard to get all of them answered. So if you have questions, bring them to class tomorrow. Tomorrow we're going to try to clean this up. And we'll kind of end there before our break. So I apologize I'm not here. I will see you all tomorrow. Spend the rest of the time in class working on the worksheet.